Okay, in this video, we're going to look at naming galaxies or classifying galaxies. This video is designed to go along with the worksheet called Name That Galaxy. So if you don't already have it, go ahead and pause the video, get that worksheet from your teacher, and then resume. All right, welcome back. First thing we're going to look at are spiral galaxy, or galaxies for plural. As you know, our galaxy, the Milky Way, is a spiral galaxy. There are numerous other spiral galaxies in the universe. And a spiral galaxy is characterized by a central bulge, which is very bright, very dense, made up of millions of stars very close together. And then a spiral galaxy has the telltale spiral arms coming out from that central bulge. Now, many scientists believe that there could be a black hole at the center of a spiral galaxy. Spiral galaxies also have dust lanes in them, so they're pretty easy to pick out. And as you've already learned, our solar system is located in a spiral galaxy called the Milky Way. We are located about 2/3 of the way from the central bulge. Not quite all the way out on the outside edge of the galaxy, but certainly not close to the center either. And if we look at our galaxy from the side, it'll look almost like a plate. And a matter of fact, you may see a plate used to model our galaxy. So let's take a look at this. If this were our Milky Way galaxy, which letter would represent where our sun is located in the galaxy? All right, if you said W, that would have been incorrect because W is at the center. That would be the central bulge. We're not located there. X is a little bit away from that central bulge, but it's still a little too close to the center of the galaxy to be our solar system. Z, on the other hand, is way on the edge, so that's too far out, so Y is the correct answer. You may also see our galaxy modeled like this, kind of an exaggerated spiral or an exaggerated pinwheel. So again, where would our galaxy be located? The answer here would be at location X. Y and W are too close to the center, and Z is not even inside the galaxy, so Z would not be correct. So remember, when you see models of our Milky Way galaxy and they ask you where the sun is located, look for a point that is close to the edge, but not all the way out. So let's look at another type of galaxy called an elliptical galaxy. An elliptical galaxy is sometimes referred to as a fuzzy snowball because they look like just patches of fuzz in the sky. Elliptical galaxies can be circular or they can be oval in shape. I prefer to call them baseball-shaped or football-shaped. Like a spiral galaxy, an elliptical galaxy can be made up of billions of stars. It does have this halo glowing effect to it. But some elliptical galaxies could be confused for a spiral galaxy, like this one called the sombrero galaxy. Notice that it has kind of a flat disk, but it lacks the spiral arms of the spiral galaxy. The third type of galaxy we're going to talk about is called an irregular galaxy. These are all the galaxies that don't fit the criteria for a spiral galaxy or an elliptical galaxy. These galaxies can be all kinds of different shapes, and sometimes it's hard to even recognize them as a galaxy rather than just a blob of stars out there. But they do have some of the characteristics of the other galaxies. There can be millions or billions of stars in them, and all of those stars are held together by gravity. Now, some of these galaxies look kind of contorted, or they look kind of distorted. And that can be due to gravity in the area, perhaps a black hole trying to draw away that mass. Some galaxies even look like nebula, and this one looks very much like a planetary nebula. All right, so get your paper out. Okay, what we're going to do is complete your graphic organizer for the Name That Galaxy worksheet. You should have it in front of you. It should look like the document I have on the screen here. And you'll notice that this is divided into 3 columns. The first one says spiral galaxies, middle one says elliptical galaxies, and the third one says irregular galaxies. And you were introduced to those in the earlier part of this video. So let's go through here and fill this in, take a few notes. You're going to find that there's a large number of similarities between the galaxies and a few differences that are very important. So let's get started. Let's start with the spiral galaxy. We know that a spiral galaxy is huge. It contains billions of stars. It actually contains stars. Can't type today. Contains stars, gas, and dust. And we know that our Milky Way galaxy is a spiral galaxy. We know that. All right, an elliptical galaxy is also huge. It also contains stars, gas, and dust. And so does an irregular galaxy. All right, so all 3 galaxies are made up of stars, gas, and dust. We know that. We know that our spiral galaxy is held together by gravity. So is an elliptical galaxy. And so are irregular galaxies. We know that a spiral galaxy is pinwheel shaped. And see the top picture to get an idea of what pinwheel shape means. We know that elliptical galaxies are either round or oval shaped. I like to think of them as either baseballs or footballs. And in irregular galaxies, they have no particular shape. That's what makes them irregular. All right, if you look at the pictures above for a spiral galaxy, you'll notice that it has a central bulge and a thin disk. It has a halo, which is a glow, and you can see that in the bottom picture. An elliptical galaxy also has a central bulge, but no disk. It also has a halo. An irregular galaxy may show signs of a disk, and a bulge, but they are usually not quite as pronounced as with the spiral galaxy and the elliptical galaxy. But irregular galaxies also have a glow, or a halo, and that halo is caused by the stars being behind it and shining through the gas. And we see that as the glow. A spiral galaxy is rich in dust and gas, and as you know, that's what's needed to form new stars. An elliptical galaxy has a little bit of cooler gas and a little bit of dust. An irregular galaxy is usually very rich in gas, and dust. So if you just look at that, which ones do you think would have the best chance of forming new stars? If you were to say spiral and irregular, you would be correct. A spiral galaxy contains new and old stars, whereas the elliptical galaxy mostly has old stars in it. You won't see many new stars forming in an elliptical galaxy. An irregular galaxy, on the other hand, is more like a spiral galaxy. You'll find that it contains new and old stars. So there you have it. That kind of gives you a little compare and contrast of those three types of galaxies. Give you a little bit of idea what's going on in them and why our galaxy is the way it is and where we live here, why we live here. So if you have any questions about galaxies, please contact your teacher and get those cleared up. All right, now that you know what the galaxies' characteristics are, the different types of galaxies and their characteristics, on the back of your paper, you will find 5 examples of galaxies. And what I would like you to do is just go down through those 5 and categorize them by the type. And in the space provided here to the right of each galaxy, just write in there whether or not that's a spiral galaxy, an elliptical galaxy, or an irregular galaxy. And when you get done with that, have your teacher check out your worksheet just to make sure you've got it done correctly, and then you'll be ready to move on. Thanks for watching this video. Good luck. Keep learning.